Alright, in this video we're going to do a related rates problem using the distance formula. So let's jump right into it with an example. So a bug crawls along a path shaped like the curve y is equal to the square root of x, where y and x are both measured in inches. If the x-coordinate of the bug's position increases at 2 inches per second, then find how quickly the distance between the bug and the point 20 is changing when the bug is at the point 2. Alright, so the first key step in solving any related rate problem is to identify any rates of change in the given problem. So again, we can identify these with rates of change like inches per second. So it says the bug's x-coordinate is increasing at 2 inches per second. So we can write that as a derivative as dx dt is equal to 2 inches per second. Alright, I don't see any other units like that, inches per second, but the question itself in a related rate problem is usually a rate of change, and that's what we're trying to find. So it's asking how quickly the distance between the bug and the point 20 is changing. Okay, so it's a change in distance, so I could write dd dt, or I'm going to use z for my distance, so dz dt is equal to question mark. Alright, so that's the first key step, is to locate all the rates of change in the given problem, including the question itself. Alright, so now that we found our rates of change in the given problem, our next step is to find some type of equation or expression that relates these variables together. So in this problem we have x, like an x-coordinate, and z for a distance. And there is a formula that relates them. It's called the distance formula. So all we have to do is look that up, and it says that the distance, I'm calling that z, is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Okay. All right, now when we find this expression, we want to make sure that things that aren't changing are fixed in this problem, that we have too many variables underneath here right now. So for example, it's asking us how quickly the distance to the point 20 is changing, but that point 20 is not changing at all, so we can plug that into this distance formula, and we can start to simplify it. So we get z is equal to the square root of x minus 2 squared, and I no longer need that x sub 2 because I don't have two x's anymore, and then plus y minus 0 squared. All right. So now we have a little bit simpler distance formula, but we can go a little bit further, because if you look at the problem, it only tells you about how quickly x is changing, and it asks you how quickly z is changing. It doesn't ask about y at all, so we really don't want this in this expression. So we can do a little substitution, namely, in this problem, we know that y is equal to the square root of x. So we can substitute that in, y is equal to the square root of x, and then we get an expression that only relates to things that are changing in the problem that we care about. Okay, so it tells us about dx dt, and it asks us about dz dt. So those are really the only things we care about. So we're going to plug that in, and we'll end up with z is equal to the square root of x minus 2 all squared plus, and when we plug in y is equal to the square root of x, we'll get the square root of x all squared, and this will all simplify down to z is equal to the square root of x minus 2 all squared plus x. So that's step number 2 in our key steps of doing a related rate problem. All right, now that we found an expression that relates together the two variables which are changing in this specific problem, our third and final key step is to take the derivative with respect to t using implicit differentiation. So again, we're going to always take derivatives with respect to time in these related rate problems. And when we do this, we just need to remember to tack on those dz dt's, dx dt's whenever we take the derivative of a variable. So for example, on the left-hand side, we need to just have dz dt. That's the derivative of z with respect to time. On the right-hand side, it's a little bit more complicated. We're going to need a couple chain rules here. But we're going to start with the outermost function, which is the square root. And the derivative of square root in general is that it sends two square roots down to the bottom. And whatever's inside the square root just remains the same. So x minus 2 all squared plus x. Then on the top, we want to put the derivative of the inside. So we'll start with the derivative of x minus 2 all squared. Using a chain rule, that's 2 times x minus 2 to the first, and then times the derivative of the inside. Now the derivative of the inside would normally just be 1, but remember we just hit a derivative of x and we need to tack on dx dt. Alright, so that's the derivative of that first term. The derivative of the second term is the derivative of x. Again, it's not 1 in this case, it's dx dt. Okay, and that's all the hard part. Now all we have to do is plug in the given information and then simplify. Alright, so after finding this derivative, all we have left is to plug in the given information and simplify it down. So, to figure out what dz dt is, we need to know what x is. Well, we're figuring out where is this bug at this time, and it is at 4, 2. Specifically, it's at x is equal to 4. Okay, we already circled off that dx dt is equal to 2 inches per second. So now we just need to plug these numbers in. So dz dt is equal to 2 times x minus 2 is 4 minus 2 times dx dt is 2 plus dx dt is again 2, and that's all over 2 times the square root of x minus 2 squared, so that'll become 4 minus 2 squared, and then plus another x, so plus another 4 under our square root. Alright, so this is all just arithmetic, and we can calculate all these numbers. On the top, if we multiply and add all those numbers, we're going to get 10. On the bottom, we're going to get 2. And then underneath the square, if you did all that simplification, we get 4 minus 2 is 2 squared, plus another 4, so the square root of 8. Okay, now this can be simplified as a fraction, but again, it depends on the problem on exactly what you want to do. Let's say that we want to round this to 2 decimals, then this is going to be 1.77. Okay, just plugging into the calculator. And then our units. The units of z is the units of distance in this problem, which is inches. And dt is the unit of time in this problem, is per second. Okay, so that's how we solve a relay rate problem using the distance formula. Again, we just use the given formula, the distance formula, we write it down, and then we're just going to plug in the information from the given problem, only using the variables that are important in the problem that they ask about or they tell us about that is changing. Okay, so if you found this video helpful, please like and subscribe. It will really help me get started with this channel and more content.